is I like practical tips, things you can just walk out of here and do, right? But then there's this whole, how do you have a better understanding of what's going on? Because if you ever run into issues, or if you're going to troubleshoot something, or you're trying to decide between different things that you're going to pick up, what's that contextual knowledge that will help you make those decisions? So I'm going to try and convey a bunch of that along the way. And I also want to talk about where things are going when it comes to the industry and Kubernetes and apps and all of this stuff. Because if you have to do any kind of planning, or you want to know where to invest your time in now, so 2-3 years out, you can meet where things are at, I'd hopefully like to give you a little bit of that as well. So that's what I hope you'll be able to walk out of here with. And hi, I'm Matt. I work for SUSE. We're an infrastructure company. But I also want to say, who is SUSE? Because when I first joined SUSE, people said, who is this company? What do they do? How long have they been around? You know, we're in the startup phase, and I've been to a lot of conferences where I've had all these stickers and shirts for companies that don't exist anymore. So I thought I'd talk a little bit about SUSE real quick. SUSE has been around for decades, right? There's SUSE Linux, if you're a Linux person, has been around since 1992, which surprised me because I used SUSE in the 90s, but not as early as 92. And it was an independent, profitable company. And then it became owned as a subsidiary by other companies. And now it's a public company. So SUSE is a public company that's the stock's traded. It's out of Germany. But in addition to just doing Linux, over the years, they've adopted other things, OpenStack, storage technologies, Cloud Foundry, Kubernetes, and other things, right? And then back last December, SUSE merged or bought Rancher, and to get it more and more into the Kubernetes space and to managing your infrastructure layer and all of those things. But there are a lot of other projects. In fact, if you stop by our booth or you look on my shirt, you're going to see a lot of other projects that we're doing to try to go beyond your basic infrastructure, or we are doing that. So I'm also an app developer. So I said I work for an infrastructure company, but I'm an app developer too. I don't know, is anybody else in the room an app developer? All right. Does anybody in here have to do application operations? Do you have to operate those applications that you happen to develop? Yeah, okay. I see more and more of that too. So I'm an app developer, and these are some of the logos for some of the technologies that I've built stuff with in the last 10 years, production stuff that's used places. There have been websites, web applications, microservices. I did some media transcoding work a few years ago that was set up as a SaaS. Even though I work at an infrastructure company, I tend to do a lot of app development. And that's what got me into the infrastructure, was how do I run these apps and run them well? Because I got stuck with it and I had to learn more and more. And these are some of the open source things that I've used to help me operate some of those applications over the years. You'll see some Kubernetes stuff and some stuff that's very much not Kubernetes, that has to do with other layers in the stack, right? Some are push-based, some are pull-based, but these are technologies I built or used to work on operating those same applications that I had to build. So I'm going to start with something simple here. How do you get your development Kubernetes? It may seem like a simple question, but it isn't. So this is something that I encountered over on Reddit the other day. And somebody said, hey, you want to run Kubernetes on your system? Just set up a VM, right? And run Docker or Podman in it. And then you've got yourself a single node. You use kubespray to get Kubernetes running inside of there. And hey, you've got this do-it-yourself setup. The reality is, though, if you're going to run something like the Docker CLI over on your Mac or Windows and you want to interact with that, you're going to have a socket there. And so now you've got to get that socket out of the VM over to the main system in a place where you've got this set up. There's all these other complication things. And if you're a do-it-yourselfer, sure. But if you're somebody who just wants to get up and going and doesn't want to have to deal with any of that, that's a real pain in the neck. If you're an app developer, if you want to work on figuring out, how do I just get my application operating? That's kind of a pain in the neck, but I see a lot of this in the Kubernetes space. Or maybe you've got this setup where they say, just run it in the public cloud, right? Public cloud's great. I know people who've been told, run your development setup in the public cloud, get going with it. And then 2-3 months later, their management comes back and says, oh my gosh, you're spending so much money. This is costing us so much to have each of these development environments in the public cloud. We have to stop doing this for each of your individual developers. It's just going to cost us too much money, because it's not cheap to do all of this, right? Especially if you get multi-node and some of these other things they'll do by default, and they'll get you the logging SaaS in there. Or maybe use one of these technologies, right? You've got K3D, which will go ahead and run K3S, the lightweight Kubernetes distribution inside of Docker, or Kind, Kubernetes in Docker. Now, Kind was originally developed for the Kubernetes project to test its own infrastructure. They needed a way to run it in their CI pipelines. And so that really its sweet spot was there, and testing Kubernetes itself. Now, people have adopted it for other things. Or the big logo is Minikube. Minikube's been around for years to let you spin up a Kubernetes environment on Mac, Windows, different environments. Its primary way of doing that these days, or it gets its most support, is by spinning it up in Docker. It has support for virtual machines, but that VM support has really gotten a lot smaller, right? And if you're on Windows, and you say you're on Windows Home, you can't create your own virtual machines. And so getting it running in WSL or something like that is something you've got to work through. It's not an easy button. And what you see, the primary focus is on Docker, right? And so Docker, if I'm going to get up and just go work with Docker myself, what do I got? I've got a container engine, which is great. I can build things, do stuff like that. But if I'm going to get Kubernetes, I get one version that they choose. And Kubernetes versions are kind of like Android versions, right? For your phone. There's so many of them out there in production. Right. And if you go to a public cloud, the latest version of Kubernetes they're probably going to give you is 2 minor versions back from the latest. And there are a lot of gotchas between those different languages, little nuances that create problems. And so that's what you're going to get with Docker. And of course, the latest Docker news. Has anybody been hit with the new pricing things with Docker that's going to get you? Right? Docker has updated their terms of service. So if you're not at a small company, your company has to start paying them now. Right? And that is every month and every person, that is a big deal. So let me introduce you to something called Rancher Desktop. Rancher Desktop is container management and Kubernetes as a desktop application. It started off in the Kubernetes space more, but it's gone to, as you have more and more of those Kubernetes tasks, you have to do that around containers. It has more of those container functions. This is how it works. Here's a basic diagram. You've got the Rancher Desktop app, and it works on Mac and Linux or Windows. Now in Windows, it sets up an environment in WSL v2, and you get Containerd, and you get K3S in that environment. So you can do all of your Kubernetes isms right in WSL. On Mac and Linux, it creates a virtual machine using QEMU. Again, it lays down Containerd and K3S, and then it lets you work with it. Now, on the native operating system side, whether you're on Windows in PowerShell or you're in another WSL distro and you want to interact with it, you've got Nerdy Control, that top thing, which is a Docker compatible-ish CLI. Now, I say compatible-ish because there's some features that the Docker CLI has that they haven't implemented there. Nerdy Control is a sub-project of Containerd designed to create that Docker compatible CLI, and it's slowly building out its features. And of course, we bundle kube control. Now we do it a little differently. The kube control that we, kube control, kubectl, whatever, the one we bundle with it will actually look at your Kubernetes version and make sure you have a compatible version of kubectl with it. Because that project only has plus or minus 1 minor version compatibility. You can run into issues along the way. So we'll detect your version and make sure you're using a compatible version. And Helm, the package manager for Kubernetes, that's all there. And they work with it. And Nerdy Control interacts with Containerd directly. It doesn't interact with Kubernetes. So you get those same kind of, that same kind of functionality you're used to right inside of Rancher Desktop. So let's go to a demo here real quick. So here I have an application running on my local host. It's deployed to Kubernetes. I have a video, the videos of Darren Shepard, who's one of the creators of Rancher, talking. And so I want to go ahead and update that. So I have my app here. Now I'm going to go ahead and build it. I'm going to go ahead and rebuild it. All right. Now I'm going to go ahead and build it. Do I have it? Tag. Oh, I must have done it elsewhere. Hold on here. This is what I get for live demos. So this is a Helm chart. And I just wanted to get this. So I'm going to go ahead and build a new version of it. Yeah. All right. So we're going to go ahead and build it. And here, this is the same kind of command you'd get with the Docker CLI. One thing that I do need to do here is because so nerdy control, so containerd has namespaces, just like Kubernetes does, but it has its own namespaces that are separate from it, kind of like a superset. So here I'm going to say, go ahead and build it into this directory or into that namespace, because that's where Kubernetes is operating. All right. Now we're going to go ahead and we're going to update this. So we'll do helm. And we'll update it to this new tag. Now, I didn't need to push it anywhere or pull it anywhere because it's loaded into containerd. It should just be there and work, right? So we'll go look at the pods. The new pod is starting up. It's running, no restarts. And the reason it was able to do that is because the container image didn't have to be pushed or pulled, which is really useful when you're in development because you don't have to have a registry in the loop or any of those other things. So I should be able to just come over here, refresh it, and there you go. The updated video's there because I made my change. All right. But we're able to do things that are more complicated than something like that. So over here, I've got another project called Kuborden. Now, Kuborden has build images, it's got base images, it does all kinds of things. And in this case, I want to go ahead and build something a little bit more. So we'll just do something simple. We'll go ahead and just build this directory. Now you'll go ahead and see, I already pulled distroless and Golang and those things. And so right now it's going ahead and it's building, it's staging, it's going through all those things to build, right? So it's got a build container that it's doing first. It's going to go ahead and build everything in Go. And then it's going to go ahead and pull in and use distroless to actually set up its run environment. And so you can see it walking through the steps. And so nerdy control is able to do all of these things to build it for you. And it's still going through here. Ooh. We'll see how the internet goes. So while it's doing that, we'll do something else in another terminal because you can do more than one thing at once. So in this case, we're going to actually just go run a regular container. And I will take port, map it to 80 and just run Nginx. All right. So here we go. We got Nginx running. And if I come over here, just take a second, and Nginx is up because the stuff comes right through to localhost, just like you'd expect. On Mac, it actually comes through to 0.0.0.0, so you can actually share it to other folks on your network. And if you do want to constrain it to just localhost, that's going to come up in a future version of Rancher Desktop. So let me just come back over here. Oh, it's still going doing go mod. So oh, here we go. It's finally exporting it. It did all those internals. And if the output looks familiar to other tools, it's because under the hood, they're actually all using the same package, BuildKit and BuildKit-D. And so all these things that you see out there building that look like this end up using that same back end. So you do get those same builds and it's based on the same specs. All right, I'm going to jump ahead here and get past the demo here. The other thing that I want to share here is a little sneak peek of something coming soon here is where I said nerdy control isn't exactly the Docker CLI. It has some limitations. Rancher Desktop has an issue they're working through to actually add real Docker CLI compatibility here. So if you're looking for a Docker CLI replacement, that will be an option here in the near future. All right. So what about all the Kubernetes APIs? There's a lot of them. This right here is a picture of a book from version 119 of Kubernetes. I didn't see a more recent published one, and it's only 684 pages. Now, this doesn't tell you how to use the API. It doesn't tell you anything other than here's the spec, here's what you put in, here's what you get out, because Kubernetes has so many resources. There's just dozens of them, and then you've got to know those things, right? If you want to deploy applications and not even deal with the operator ones, you're still talking about 2/3 of all the resources you might end up interacting with. So let's take something simple like WordPress, right? WordPress, it's simple to deploy, right? You got a simple app server, you're running a database. Well, these are all the things you might need to actually go run it in production. You've got a deployment to run WordPress, a stateful set to run your database, horizontal pod auto scaling if you're going to do any kind of scaling at all, right? Ingress, so traffic gets routed. Services to export those things for ingress so things can talk to each other, and secrets to hold your credentials, because you got to share your database password between your database and WordPress, right? You end up with all of these things, and some of them you end up with multiple, right? And that ends up being over 500 lines of YAML that you have to end up creating or crafting or have something generated. That's not small. And WordPress is a pretty simple application. It's not one of those more complicated things or complicated microservice structures you're going to deploy. It's that simple example people put up there to try to just showcase things. And simple is 500 lines of YAML. So let's compare that to Heroku for a minute here, right? In Heroku, here's the simple things you got to do. A little bit of JSON, and a handful of commands. You can probably read a post on that in 5 minutes and get something up and running. It's simple, it's easy. That's a far cry different from what you're going to get when you go to run something in Kubernetes, especially when it comes to knowledge. I can walk into Heroku with very little knowledge. If I walk into Kubernetes, I got to go learn about all these. I don't even know which types I've got to start with, right? I got to learn which types I need to set things up, and then the structure to them and how to use them well, right? One is fun in 5 minutes. The other one takes a lot longer. And along the way, some of the things you may not have noticed here, right? There's add-ons, right? Some SaaS services that make it easy. And one of them here is going to give you SendGrid. So your thing can send out emails to reset passwords and stuff like that. That wasn't included in the Kubernetes example that I gave you. So you actually get more out of this. And of course, if you're using something like Heroku and some of those add-ons, you get a nice way to see your logs. You get a nice way to do APM monitoring, something you don't get in Kubernetes, right? And it's not built in there. It's not easy to get to. And so we've got to ask ourselves, why is there such a big difference between running something in Kubernetes and running something in a place like Heroku? And this is why. Kelsey Hightower made a very clear remark a few years ago. It's because Kubernetes is a platform to build platforms. It's a better place to start, not the end game, right? Kubernetes is not what every end user should end up interacting with. And over on the Kubernetes project, one of the things that we've talked about for years is that Kubernetes manifests are kind of like assembly language. They're really powerful for constructing things, but they're not that platform you want to expose to everybody to use, right? I mean, if you write software, how many of you write in assembly? Yeah, I didn't expect any hands to go up, right? I haven't done that in years, but that's kind of the way we view it. And we are looking in the Kubernetes project for people to build platforms on top of it to make the world easier. In fact, this is a Heroku job posting, a snippet from it. And I underlined a couple of things, and it talked about their primary toolbox. And what else? Kubernetes. If you didn't know this, Heroku actually will use Kubernetes under the hood. If you follow their blog posts and their hiring over the years, you see that they use that under the hood. Why? Because it's a great platform to build an easier platform. All right. So I wanted to take a sidebar here for a second, just to talk about where Kubernetes came from, because I think that helps understand why you have this situation. If you go back to Google, and Google's published a book, this is their 3rd edition of the book, that talks about their data centers. So they'll set up a warehouse, and inside that warehouse, they've just got rows and rows of servers, and they'll divide it up almost into like availability zones. And then they'll run Borg, their operating system, on an availability zone. And then on each of those, they just run their applications, production, development, testing, everything. And they do it this way so they can upgrade things. Or if a problem takes down one, it doesn't take down that whole geographical location. But so you've got Borg running things, and you run a lot of it. And so if some servers go down, apps just rescheduled onto other servers, right? And you can run things, you can get a higher resource utilization out of it doing it that way. There's a lot of benefits to this. And this is, again, Google's book on it. And then if you go look, Kubernetes is really, it came out of Google based on Borg. And so they had Borg originally, then they created Omega as a project, which was gonna kind of the next generation. And Omega didn't go into production anywhere, but they folded features of it back into Borg. And then Kubernetes is kind of that 3rd generation that came out into the open source world, designed to work around the way Google ran these machines in this setup, right? And on top of all of this, right, they've got Borg, they got everything. They actually built platforms on top of it. There were things like JSONit and other tools that they built to kind of make managing applications easier on top of Borg, right? It's that whole same thing. And so if you go look at, and this is the CNCF survey that looked at what is your job function, right? And you look at it, and the top thing is SRE or DevOps. And then you get software architects and back-end folks. Why? Because Kubernetes and this whole space was built around backend folks managing infrastructure. And if you really want to make it easier, you need better tools on top of that to make your application operations better, which was the expectation over at Google. And it's what we talk about in the Kubernetes space, looking for those. It's kind of been there. So that's kind of that backdrop of why we are where we are with Kubernetes being complicated. So can we do better than Kubernetes for this stuff? Or maybe don't we already have something better than Kubernetes? Because it's been Kubernetes years. Don't we have something better to make this easier already? Hasn't there been something? And here's the first thing to note, right? People talk about you don't need a platform with Kubernetes, but the reality is if you go around, people are building tons of custom platforms on top of Kubernetes at all these different companies. They take that kind of kernel, build my own user land around it that customizes it, and you've got a bunch of them out there. I know consultancies that go around and have just done this, go to different companies, building out different platforms all the time because they don't have that platform that sits well on top of it. And here's an example from Stripe. Stripe put this up a few years ago. They didn't want to handle their developers running cron and Kubernetes. So they came up with a simpler way to do this, right? Here's a simple schema for a YAML file that anybody can create. They don't have to go learn any complicated Kubernetes stuff. And they could then translate this into cron jobs and run it in Kubernetes there. So much simpler. This is a platform built on top of Kubernetes, and it's their own one-off. And if you look, there are projects that have actually come and gone already. Here's 2 projects designed to make things easier running on Kubernetes that have come to life, had their successful time, and actually gone away. Now these, when I say their successful time, it was actually corporate business decisions, companies being bought and sold, and just changes in companies are the reason these aren't around anymore. Because we've had enough time where some projects have come and gone, right? And here's some projects that they're not built for Kubernetes, but they're PaaSes, built that have kind of a Kubernetes plugin in some way so they can use it for scheduling. Because even existing platforms, even existing PaaSes have gone ahead and tried to figure out how do I work with that scheduler Kubernetes so I can play in that space. And of course, Cloud Foundry has not just done Kubernetes integration once, they've done it twice. One time is Pivotal VMware, and the other time is all the partners who work on it separately from that. They actually did 2 different implementations. kubecf came first, and then there is CF for Kates is the more recent one. And you see they've actually gone through this twice now just to play with that back end. Now, they have their own scheduler. Cloud Foundry's long had its own scheduler. There were DEAs, then they rewrote them in Go, and they called them Diego. They've had their own scheduling engine, but it's that same idea as Kubernetes along the way. So they just tried to come up with a way to plug into it. And then there are the proprietary PaaSes. Now, because they get you that lock-in, I'm not going to put them up there and shame them, but there are proprietary ones that have come out here in the Kubernetes space as well to try to do this, right? And then there are these tools that say, hey, look, we're a platform, we're a PaaS, but they are not. They're building blocks you can use to build your own platform with, right? Because we developers love to build building blocks, Legos, and then place them together, and we end up with all of these things. And why do we have a bunch of projects that call themselves platforms but are really Legos? Comes back to this. A bunch of DevOps and SRE folks, we like to build our own platforms, and we end up with all of these custom platforms. It's in some ways, I think of it like Linux distros. You end up with all these different Linux distros off the same parts. And so that's the same kind of thing that lots of companies are doing for each of their own. So can we do better than Kubernetes APIs for the developers? Let me tell you about Opinio. Opinio is a project that is a PaaS, and it is for your application developers, people who want to do things at edge and build out that kind of thing. Now, I'm not going to do a live demo for this one, but I will tell you more about it. One, it's designed to scale down to a laptop all the way up to a cluster. And I think this is important. It was one of those things. A long time ago, I was a Cloud Foundry user. Has anybody heard of Staccato? It was a Cloud Foundry distribution from back in the day. And Staccato, I could run on my developer laptop 7, 8 years ago and still be productive on it. And it was Cloud Foundry. And then I could go run it in a cluster. And it was amazing to have that development environment right on my system without any pain. And so this is designed to scale. All the screenshots and everything that I did on this laptop with 16 gigs of RAM. without any issues. And I was running other things. I had 400 tabs open in my browser. I have a problem. I know it. I had Slack open. I would do video conference calls. I could do all these things while I had it running in Rancher Desktop, all of this stuff, because scaling small is important. And it scales all the way up to clusters. And so here's installing Opinio, right? Right now, it's a one simple command. You can see it at the top there. And you'll see it installs or uses things that are already there. It'll use min.io. It installs a registry. It uses Tecton for building. It's got Cert Manager in there. And the reason it'll install this stuff all in, if it's small, right? It'll use Trafic for some of the routing. It can scale down and it'll install if it's not there. But if you're going to a bigger installation, you've got your own registry, that's HA. You've got, your own S3 compatible interface, maybe something that's built for HA and all this stuff. It can tie into those things as well when you install it and get up and running. So you can go from small to really big and even customize it. But as a developer, right, one command gets it up and running. And as an ops person, it's something that you can configure and run for others in your cluster. So it's designed to go from small to big. Here I am pushing an application, right? And you'll see here, you can have a configuration file in the directory with the application, or you can pass things in, such as the name I want it to use and the path, right? And here you can see it installing my application. And it grabs that stuff, it grabs the thing, and it sends it into Opinio. And just like any other PaaS, on the next screen here, you'll see it detects. So right at the top, you see it's detecting. What is the code base? In this case, it was PHP. I just chose a simple PHP app. It could pick Node.js or Python or Go or any of those things. It'll detect what it is in order to build it. And then it's using build packs in order to generate container images for those things so it can run it. Now, you'll see there's a bunch of things going on here, like Pacato build packs, right? All this stuff is cloud native projects. A bunch of it's through the CNCF. It's proven stuff, CNCF projects, open source. And this is tying it together in a way to make it accessible, right? And in the end, it ends up creating that PHP container and then launching it into a cluster and giving you a URL where you can go visit it at, right? And it tells you where that is. Now, all of this is configurable. You want to choose your custom URL or any of those things. All that can be done. This is just the simple developer use case, right? And there it is, right? My simple PHP app. It shows up, it gives you some version information, that kind of thing. But it takes the pain out of building it. And I think that's a really important step here. If you don't want to have to build your containers or figure out what needs to be involved, it makes it a lot easier. And of course, right, nothing would be out there if it didn't have nice IDE integration. And so you can see working in VS Code integration, so you can push, pull. Here you can see getting to the logs of the running application right inside of VS Code. Because these are important, right? Integrate it with your environment, make it one click to do. So you don't even have to jump down to terminal, right? How can we make things easier? That's kind of one of the goals. But then you got to ask the question of how do you run your services, right? And quite frankly, Opinio does not have an answer to that yet. It's something we're working on, but it turns out it's complicated. And it's complicated for two reasons. One is, well, are you going to run it as a SaaS or are you going to run it yourself? Some companies won't let you install your own SaaS or operator or anything else into your cluster. You're stuck having to run it yourself.